Welcome to Premath. In this video tutorial, we have got this right angle isosceles triangle, and in this triangle we have got this circle that is inscribed in it. And moreover, the side lengths of this triangle are 2 units each. And now we are going to find the area of this green shaded circle. So let's go ahead and get started with the solution. And here's the very first step. Let's focus on this triangle ABC. And over here in this triangle, we know that this side AB is 2 units and this side BC is 2 units as well. And since this is a right triangle, therefore we are going to use the Pythagorean theorem. And here's the Pythagorean theorem. A square plus b square equal to c square. In our case, the longest leg is AC. I'm going to call this side C. This horizontal side of this triangle I'm going to call A. And this vertical side I'm going to call B. And here's our Pythagorean formula. Let's go ahead and fill in the blanks. A in our case is 2. So that's going to become 2 square plus b in our case is 2 again, so that's going to become 2 square equal to c square. So 2 square is 4 plus 4 equal to c square, so c square is going to give us 8. Let's take the square root on both sides to undo this square, so c is going to be simply square root of 8. And now you can see this square root of 8, I have just copied it down and I just simplified it, and the reduced and the simplified form is going to be a 2 times square root of 2. So I can write this c equal to 2 times square root of 2. And we can see that this side c is same as this distance AC. So I can write this one as AC equal to 2 times square root of 2. And here's our next step. Let's focus on this inscribed circle. Let's go ahead and connect points O and D. So let me go ahead and connect that one, O and D. And likewise, we are going to connect point O and E. And here's our much nicer looking diagram. Let me call this radius as lowercase r. Therefore, OD equals to r and OE equals to r as well. Now let's recall tangent to a circle theorem. And here's a tangent to a circle theorem. The angle between a tangent and a radius is always 90 degrees. That means they are perpendicular. In our case, this radius and this tangent line, they have a 90-degree angle, and likewise this one is 90 degree again. And here's our next step. Let's consider this square BEOD. Here's the definition of a square. All sides have equal lengths and every interior angle is a right angle. That means 90 degrees. Therefore, this BE equals to R, and likewise DB equals to R as well. Now let's look at this AB distance is 2, isn't it? And this BE is R. So therefore this distance EA is going to be 2 minus R. Thus our EA distance is 2 minus R. Now let's look at the other side, this BC. We know that this total distance is 2. We know this BD is R. Then this distance CD is going to be 2 minus R. So the CD distance turns out to be a 2 minus R as well. And now in this next step, let's recall this 2 tangent theorem. And here's a 2 tangent theorem. If 2 tangent segments are drawn to a circle from the same external point, then segments are equal in length, as you can see in this figure. So therefore, according to this theorem, this tangent line is going to be equal to this one. No wonder I put down CD equal to CF. And since CD is 2 minus R, so therefore this CF is going to be a 2 minus R as well. And likewise on this side, this tangent EA is going to be equal to AF. And since EA is 2 minus R, then AF is going to be 2 minus R as well. Now let's focus on this line segment AC, which we can see equal to this CF and then plus AF, isn't it? So in our case, CF is 2 minus R and AF is 2 minus R as well. So let's go ahead and simplify. In our case, AC is 2 times square root of 2. Let's write down 2 times square root of 2 equal to CF in our case is 2 minus R plus again AF is 2 minus R again. So let's simplify. That's going to give us 2 times square root of 2 and here 4 minus 2R. Let's divide across the board by 2 to make things simple. So that is going to give us square root of 2 equals to 2 minus R. That means R value is going to be simply 2 minus square root of 2. And here's our final step. Let's recall the area of a circle formula. And here's a circle formula, A equal to pi R square, where R is 2 minus square root of 2. Let's go ahead and fill in the blanks. So area equal to pi times 2 minus square root of 2 and then square. Now let's focus on this square part over here. I have just copied it down over here and we are going to simplify this one. And then we can put this square as the product of this one twice. And let's do the double distribution. We call it FOIL method, and here we multiplied this one out, and here our simplified answer turns out to be a 6 minus 4 times square root of 2. So that means this part could be written as area equal to pi times 6 minus 4 times square root of 2, and that is our area. Thus here is our area of a circle, and if we replace pi by 3.14 approximately equal to, and square root of 2 is approximately equal to 1.4142, then our area is going to be approximately equal to 1.08 square units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.